Hello everybody, this is Dr. Balkanite coming at you. I just want to do this quick video for you about your homework assignment that will be due next Wednesday. I'm going to do a review sheet of the information from the EIA, the Energy Information Administration, and see how much coal, natural gas, oil we have out there, how much renewable energies we use in the United States, and all that rigmarole. So I think this will be fun, and I hope it's very informative to you. For you. All right, it's kind of eye-opening every time I go back and review the data that's on there. And get this website keeps on getting better and better each year. I'm amazed. All right. First thing I want you to do, though, I posted this Word document up on Blackboard for you. All right. It is just your homework assignment. All right. The first thing I want you to do is watch this video. All right, from Jon Stewart, the Comedy Central. It's very funny, but I think it's kind of shocking and kind of intuitive about the situation we're in today. All right, and then at the very end, I ask you a question about this video to see if we can really be energy independent here in the United States. Okay. So what we're going to do is, the primary purpose of this homework is to review the Energy Information Administration's website and see what's out there. Okay, so the EIA, the U.S. Energy Information Administration, is a data collection website. All right, they collect all the data of how much oil, natural gas, coal, solar, wind, all the energy forms that we use, how much we have in the ground, how much we consume, and all this other rigmarole. I mean, what the prices are and what cost of drilling is, cost of solar panels, and it's getting better and better each year for us. All right, you're getting more and more data out there, but it's only a data collection source. It does not make the policies for the United States government. That is in a different division that's called the Energy Department, and an individual called Rick Perry is the head of that. All right. So if Obama wanted it, or if Trump wanted to do, or any president wanted to do a policy, they would go to the Energy Department and talk to their energy czar about that. All right. They do not go to the EIA. EIA is just data. The Energy Department will go to the EIA and say, how much have we done, or how much, what's going on? Give me the data, and then they'll take that data and then set the policy. All right, and a lot of people, if you're going to write a blog or a research paper or anything with any substance to it, and you need the good hard numbers about the energy uses and prices about America, you come to the EIA. All right, it is a nonpartisan, information only source. It does do some forecasting out there. You can see the outlooks, energy outlooks going on, but they just got the past data and they just say, forecasted in the future. That's more just, economic modeling. That's all. All right. But they don't set the policies. They say, hey, if we keep up this pace, we'll have this. We drop it here, we'll have this. Okay. So policy is not their deal. It is them getting all the information to us. So there's a lot of different things here. So you can get all your sources are broken out. All right, to petroleum, your natural gas, your electricity consumption, total energy, nuclear, renewable, and coal. So you can find all your different information out there. Okay. The first thing I want you to do, though, is to go to the tools, and I have the website here for you too, right, for the glossary. Go to the glossary and put in these terms. And I just want you to do these terms, verify that we're kind of on the same page. The Energy Information Administration, not talking about anything different from the book or what you kind of have in your head, all right? But I think it's important that you know where these terms that you're looking up are and what they are, all right? So you can, just go in there and put in a term, and I know you can cut and paste these definitions, and that's okay, but at least you read them, I hope. All right, I don't expect you to type and just cut and paste them and put them in there. All right, but I just want you to get know what proven reserves are, what crude oil is, least constant state. All right, and what a coal analysis is, and a coal grade, and wind energy, solar energy, all this stuff. All right, not too many of these terms, but I just give you a sample of that everybody's kind of on the same page when we talk about this information. Okay. And now we're getting into the fun stuff, I think, okay? So what I want you to do is actually fill out this chart, All right, so first we're going to ask what the United States proven reserves are of total oil plus least condensate, total natural gas, and total coal. All right, so we're going to find out how much oil, basically, how much natural gas, and how much coal we think we have in the ground that we can pull out of America. All right, and I have all these websites links here for you, so you don't have to go searching around. I thought about having you search around, but it can get kind of confusing. So I put these websites, or the links to you, for you. All right, here right underneath the numbers. So here you got the crude oil plus least condensate. All right. So proven reserves as of December 31st is 35,000. Oh, first we've got to check out our units of measurement, right? So in the first thing we have the units of measurement. So always look for units of measurement. And this one is in millions of barrels. Okay, so to read this, we say that we have 35,213,000,000 barrels of oil left in the ground as of 2016. Okay, that is what we think. And you can see right here is all these adjustments and things like that that go through. All right, but this is the total of kind of like all these revisions and decreases and things like that. All right, and if you wanted to, you can even click on this little thing on the end and graph it. All right, so it graphs the proven reserves for us, or you can actually put in the proven reserves and the estimated production and graph that by going up here and hitting graph, and that gets both of them. All right, so look at these different graphs and look at them graphically too. Just don't look at the numbers. Okay, and here we also have the estimated production down here too. So estimated production, this is in millions of barrels, so it'll be 2,223,000,000 barrels of oil a year is produced here in America. So we put our units of measurements in and amount, okay, in the year. We want to make sure they're both on 2016, right? And then productions right here for the oil too, okay? So we'll put those in there, and then at the end, we have years remaining of oil. Years remaining is just basically the current reserves of what we have divided by the current production. And that will give us how many years we have left of oil in the ground. All right. Of course, we could always find more oil. All right. And that would increase the years most likely. All right. Or we can, say drill a couple wells and say that oil wasn't there and take it off the books. Okay. That happens as well. Or, our current production. Our production rate can go up or go down, and that also will change our years. I just want a snapshot of today. What's it like today? If we didn't find any more oil and didn't change our current consumption rate, how many years it would be. So we would divide this in, take this unit of measurement and make sure they're consistent, all right? And then divide that and just say, let's just hypothetically, I'll pick a number out of the air and say it was 10 years. So I put 10 years remaining. That's what I ended up when I divided these two numbers. Okay. And then year ending. So if it was 10 years of 2018 right now, we'll say it's 2028. We'll run out of oil here in the United States. Easy enough? Well, I hope you get it. All right. So I'm doing this. And then we got the natural gas. So this one's a little bit different. It's just kind of as complicated as coal. Not complicated, but it's a little bit different. See, natural gas doesn't have both of them in the same thing. All right. And there's a lot of different natural gas. So if we just go to data and exploration reserves, you can see there's a lot of different stuff on that. All right. So what we're going to do is actually use this one. Natural gas after separation. We're going to make sure that is the right site, because this one will have all of them for you. All right, all of them. Yeah, natural gas proved reserves after separation. So this has all the natural gas in it. All right, so all those lists that you saw underneath there are going to be in there, and it breaks it out to different states and things like that for you. But we just want the total. All right. So here is the total in the year of 2016. All right, and this is in billions of cubic feet. All right, so 341,133,000,000,000 will be how you read this. Okay, and like you can also view the history, graph it for you. All right, didn't really find too much, and we found some more, and then it went down. Okay. of proven reserves. So some of those wells did not actually pan out, and we had to drop them off, okay, because we're doing a lot of fracking now. All right, so look at these different graphs that go off, okay? So this will be your total amount, all right? This will be your units of measurement, okay? And this will be your year 2016. All right, then in the production down here, we have a different one because the production wasn't on there. That was proven reserves. So we look at the gross withdrawals and production, all right? Make sure it's an annual millions of cubic feet. So sometimes it could be a monthly. We wanted to have the annual because that's what our last one was in, also annual. All right, you got to make sure those are there too. All right, but if you would see if this was actually monthly. Oh, I guess it didn't change. I wonder why that monthly million. I wonder why that didn't change for us. Oh, I guess it did. See, October, just the last couple years, or just the last couple months. But if we put it into millions of cubic feet annually, now we'll get the years up here. All right, so you got to make sure you got your units of years and months. You got, get those mixed up. So it's 2016 is a year. This time though, it is actually in millions of cubic feet, right? So we need to convert this millions of withdrawal and production from millions to billions or billions to millions. Okay, so you got to make sure you're doing your units of math right here on this. Units of math correctly before you start dividing. Make sure those units are equal. Okay, and also you can see the view history, so you can see that we've production has gone up steadily throughout the time since the 1940s in our gas. All right, 1970 we hit a lot, and then it's gone back up. Okay, so don't be afraid to hit these graphs and look around too while you're here. All right, let's see Pennsylvania. What has happened in Pennsylvania? Whoa! Holy guacamole! We're starting to frack, I think, in Pennsylvania back in 2010. Huh? That's pretty exciting. That's, they're talking about fracking all over the place. Okay? Pretty neat, huh? So that's why I love this website. You can just find about anything you want. All right? Wow, man, I'm going to go check that. That's the first time I opened that thing, so I want to check that out again. See, this is the production withdrawals of Pennsylvania. All right, let me see that. Where is that again? Pennsylvania. And this is what I call a J-curve starting to form. Okay? A steep incline of exponential growth. Right? And I see J-curve. It doesn't mean good or bad. It just means something is going on that we need to stop and think about. Just right, this little J that's starting to show up. Okay, it's tending to bend over here back in 2014 to 2015. I would assume this is production. I would go back and check the prices of natural gas, right, and see that back here we're talking about $13 a cubic foot per price, and over here when it starts bending over, we're talking about $3 a cubic foot for price. And production definitely would have kind of stabilized during that time, but I could be wrong. Okay, but when I see this, I want to know why this kind of stuff is happening. Okay, I wonder what it was like with the proven reserves. Let's go back to that proven reserves and see what that's like. I'm sorry, I just like this this website. So let's go to proven reserves and see if that was Pennsylvania's in here. See if our proven reserves have changed any. Whoa! This is this is still gross withdrawals. So that's still the same graph. I wonder why that was. Gross withdrawals and production. So this is reserves. Open this up. Proven reserves at the West. Okay, so now I'm on the right place. This better end up being a little bit. Natural gas after what separates proven reserves, and we have this jump right here. All right, maybe that Marsala, when we started doing it, those reserves weren't proven yet. Okay, and you'll decide. You'll see what the definition of proven reserves are. It's one of the definitions we have. Okay, but it's kind of relates to what we've actually produced too. Right? Interesting. Very interesting. Sorry, I took that diversion there. Do the same thing with the oil and then the natural gas and then the coal. I got two websites or two links here for the coal reserves. Make sure you check your units and measurements for the coal as well. All right, you got to have them. They have to be equal for when we're doing the remaining years left. Okay. Next thing we're going to do is look for the cost of the oil and how much it costs to drill and oil over time. So open up that website and you'll see. I want you to actually, you see that here's the cost, but we're going to look at this graphically. So I want you to hit the real dollars on both of these, okay? And then up here is the graph, and hit the graph. I'm not going to do it for you because I want to surprise you, or you know, I don't want to give away the homework yet, okay? And real dollars just means that we're adjusting for inflation, okay? So if you look down at this little notes, it's changed to the $2,000, so $2,000 amount. So they put the index for inflation. All right. So they make sure that all these dollars are the same. $1989 had the same purchasing power as 2000 and 2000 and of 2018 or whatever 2007 this goes up to. So it's just adjusted for inflation. So it makes the dollars more real. All right. Nominal dollars would just be without inflation. Okay. And you don't really see a good number for that. I mean, the number is real, all right, and it's okay, but you got to remember that $1 in 1980 was not as powerful as $1 is today. Okay, it's called inflation. All right, so do that one, and then you'll see here. Now we're going to go to review the price of oil, of gasoline. All right, and look how much the gasoline prices have changed. So we're going to look at the cost of drilling, and then the cost of gas and the cost of natural gas, right, of gasoline for our cars and natural gas for our homes. See if the price and the cost of drilling kind of look the same, all right. Compare those two graphs. Energy, then we're going to go to renewable energies, all right. And the first thing we're going to do is open up this hyperlink, all right, and you got the energy overview, all right. This just pops up everything, so I want you to, you know, take a look at this picture when we're putting. I want you to actually put these graphs into the assignment, so you can either download the image, okay, or you can just take a screenshot if you want. I haven't told you that yet, okay. So we're going to look at that, but then we're going to click renewable energy production and consumption in the same chart in primary, and then we're going to hit the primary energy source interactive. So we're going to change this to renewable energies. And we're going to hit table 1, renewable energy production and consumption. Okay, and hence the graph. All right, and this breaks it down to biomass, to hydroelectric, the wind, the solar, and to what's way down here, geothermal. Okay, so it just breaks them down. Just follow these links. All right, so I want you to do solar. All right, I want you to do some wind. I want you to do some biofuels, some ethanol, and see what happens with the ethanol, and also the biodiesel. And like I said, each time you do one, just either download the image, or you can cut, or you can screenshot the graphs in there, and then explain the graphs what you think you see. All right, and then at the very end, I ask you to go back to the video, and I ask you to you watch at the beginning. And ask you to, what do you think? Can America be energy independent? Are we on the track to do so? All right. If not, what do we need to do? Okay. So I hope you like this assignment. I think it should be fun and interesting. Please feel free to really look around this EIA website. A very powerful website where you can find a lot of different information. Okay. So I hope you like this video and enjoyed this assignment. If you have any questions, please do not hesitate to email me. Thanks. Bye-bye.